I've ever seen in Columbia. So, good job.
We used to have bigger ones.
Did you?
Yeah, before Chris ran it.
Oh, okay, okay.
Back before Tor ran it.
Okay, yeah.
I remember the guy before that. It was too long ago. I'm getting too old.
Yeah. Well, in our group in Greenville was, in the early days of .NET, was much bigger. I mean, it's twice the size as far as people showing up as it is today because new stuff, everybody wants to learn it, right? Now that .NET's been around for 18 years, it's not new stuff, right? So, anyway, without further ado, today we're going to talk about choosing a data access approach. And just real quickly about me, my name's Joe Walling. I stopped the counter at 25 plus years. I run Walling Info Systems, which is a custom software development business, and I have a dump truck dispatching system that we've spun out as a separate company now too. And as I said, I run the Greenville Spartanburg Developers Guild. Today, we're going to talk a lot about choosing data approaches. There's a lot of thoughts out there or opinions out there and a little bit of data, and a lot of time the opinions don't necessarily match the data. So we're going to go through this and try to separate fact from fiction. You know, what may be someone, you know, some people love entity framework and I'm going to use it everywhere, and other people, well, I hate the performance entity framework, so I'm not going to use it anywhere. Where is it best used? Looking at some of these other approaches, Dapper, ADO.NET, maybe even, you know, real quick glance at, you know, the concept of other types of databases. How does that fit into the type of development we do today, right? And once again, I'm going to try and make it fact-based. We'll look at a bunch of benchmarks. I've gone out and actually benchmarked these things to see, to try to help you separate that fact from fiction. And we'll look at entity, then some specifics on entity framework and what you can do to improve their performance. You know, look at a few tools and several opportunities for improvement. There's a lot of entity framework code I've seen written, and when you look at it, you say, yeah, we do that all the time. And then when I show you the performance difference, you say, well, maybe we shouldn't quite do it that way, and we ought to add another dot something to it, or, you know, just a subtle change, and you see tremendous performance improvements. So at the end of this, you should be familiar with the factors involved in choosing a data access approach. You'll understand the relative performance characteristics, and you'll be able to diagnose issues with performance in your data layer. And that's, you know, it's like, okay, well, wait a minute, I got the database over here, and I got my app over here. How do I see what's happening between them? And we'll talk about a few of the ways that you can readily discern that. Now, how many people in here use entity framework? How many people in here have an aversion to entity framework for one reason or another? Why? Just out of curiosity.
Sometimes some of the overhead and the string input,
Yeah.
the validation is nice, but it's not always necessary for maybe something quick prototyping. We want to scaffold up something to the back end. It's a minor complaint.
Is it more a scaffolding thing or more of a performance thing?
Sometimes it's a performance thing if you can end up in little traps where maybe something external doesn't really need to in real time, or make sure this is right, update. Anything that's going to be represented from a table.
Okay.
Meaning, sorry, it was my flat one. Meaning I don't need everything always scaffolded up right, that I need to call into an object immediately.
Right. Lot of overhead and infrastructure to carry along when you only want to do something quick and be done with it, right? Okay. Is that what you're saying? Okay. I just wanted to repeat it because those live streaming might not be able to catch that. So we'll start out, we're going to review some benchmark code, and then we'll go and look at some benchmarks. So let's first, because I know you all want to get into some code. Okay, so let's start out. If I can find my mouse, there we go. And what we have here And I've commented things out because I'm going to, rather than, in this case, because of the network or not going out the internet, a lot of times I'm just going to show you numbers that I've done in advance of this so you're not sitting waiting, because this benchmark program isn't, we've all used a timer, right? Well, we'll start a timer here and we'll end a timer there, and that's how long it takes. But then if you do a bunch of those, you see, well, wait a minute, it took this long here, and it took less here, and then more here, and you got numbers all over the place. So, and you got to do a warm-up, because if you haven't done a warm-up, then, and now what happens if my computer's running something else just for that short time that I'm trying to access that database, and trying to separate out all these external constraints that are running on your computer and randomly popping up from when you push that button. So there's this framework for running benchmarks, and it goes through and it'll, you know, for one thing, it forces you to be in release mode because it doesn't want debugging going on and, you know, that overhead with it to affect your numbers. And then it starts running how long is it taking to run this code, and it will run it till it's statistically significant. So you'll see that sometimes it may run 30 times, other times it may run 15 times, and you don't necessarily want to sit here and wait through me to run every one of these examples while you're sitting here waiting for them to run, especially if I'm going out via a phone out to, most of these are being done against an Azure SQL database. So just point that out in advance. But so here's where it all starts, and we're just setting up benchmark runner.run, and what it does is it's going to go into the benchmark class, and it's looking for anything that has an attribute of benchmark on it. Okay, it knows, you know, once I uncomment these, it knows that's what I want running in my benchmark. Okay, does that make sense? And if you look at, you know, we can just look at an example here. You know, there's some code. Now, you don't need to know how, you know, we don't need to dig into the code. The benchmark app is an open source app. I'll make this code available for you so you can go out and get it if you want, and then you can run your own benchmarks, because we'll have more talk about what do these results mean in a very short while. Yes?
It's just called the benchmark app?
It's benchmark, let's see. I'm trying to think, let's look at the, yeah, performance, benchmark dependencies. There's a NuGet package, benchmark.net is the name of it. So you can just go out and get that and bring it in, and then it runs as a console app to show you your numbers. And throughout this, we'll run through one or two of those so you'll see what kind of display it gives you. So let's go to so here's an example of the main output. Now before this, there's a whole bunch of I'm doing this, I'm doing this, I'm doing this, you know, and you see each of the individual runs and the time it's taken on the run. But at the end, it puts together a table that looks like this. So that's what I like about it, is you can set up a whole bunch of different runs, and then you can come out and you can see, come on, okay. I can't, can you guys, I wasn't sure if it's a reflection. Can you see the red on that or not? Yeah, I guess the angle of incidence is such that it's not displaying on that. But anyway, you see the different, this is get player by ID entity framework, and we'll look at that code in a minute. Get player by ID entity framework, no tracking. That's what the NT means, no tracking. Here's the Dapper version. For those who don't know, Dapper is a micro ORM. It's a very lightweight product, doesn't have all the overhead that you have with something like an entity framework. And then we have good old ADO.NET for those that still want to live in that world. But we're going to look at a code example, and yeah, you'll wonder, wait a minute, why do I do all these lines of code when I can just do these couple lines of code and get the same results? And the same thing, we got entity framework, no tracking, all for, through 3 different sets of queries. And I'm short one on the last one because I ran out of time setting it up for the ADO, trying to get it to exactly match what we were getting on the others. And I said, they'll get the gist of it from this, so we just stopped at that. But if you look at it, well, what's it tell you? Any conclusions? What's better? What's faster? Depends, right? I mean, you look at some examples, well, the ADO.NET was faster, but you look at another, the Dapper was faster, and you look at another, and when you look at it, well, we're talking 34 milliseconds there, 34.26 versus 34.4.
I thought like the node tracking is faster, but what throws me off is the last one. The node tracking is at 65.82.
Yeah, you could have.
Node tracking, because my personal thing, we had written code initially, it was slow. Then we thought, okay, now we have to do node tracking and only node related entities, so it will load faster. That's we personally did that. But I don't know why the node tracking here is taking more time.
Yeah, and you're right. In general, no tracking will generally turn out ahead of. But I show you that where, well, it didn't happen to be the case there, did it? Those are the numbers I got, on one of the runs. So beware of benchmarks. Here's another benchmark what those same tests run. Point here I'm trying to make is when you see, you just see numbers out there somewhere on the internet. I mean, we know it's on the internet, it must be true, right? But you need to understand where those numbers came from. And a lot of the time, well, some people may say, well, I like the way those numbers line up better. They're more what I expected, right? They probably are closer to what you were expecting. But they take out a lot of factors. Yes, sir.
I'm not an entity framework guy, so can you tell me what node tracking means?
It,
Between EF and EF.
the no tracking means we're not going to keep track of the state and the history of the entity framework objects. In other words, I don't need to know that these things have happened to it in the past because, say it's a web app and I'm just bringing the data back and I'm not keeping up with it's changed to this and then it changed to this. I'm only going to get it one time. So a lot of your query stuff, there's no reason in the world to be set up. Well, I shouldn't say there's no reason in the world. There's probably not many reasons that you'd want to set them up with tracking running on them because you're doing a one-shot deal and you're not changing the state of anything.
But none of the others have tracking.
Right. So
Like you're comparing apples to anything.
right. There's extra functionality in any framework to handle that tracking. So, and you're right. So the others don't do that tracking. You have to do that tracking. You have to write the code to do it. So when you need to have the capabilities for that tracking, then you're willing to take a little bit of a performance hit if you don't have to write all that code to do that tracking. So I just show the 2 examples because there are times when the tracking can really slow down performance, and in some cases when that's happening, you don't even need to have the tracking on. Okay? So that's the only reason I broke it out as separate. The concept of the tracking and the specifics of what it does is beyond what we're showing here, but just know it's extra stuff you can do that you don't get out of the box with ADO.NET or Dapper or anything. It keeps track of the state of the entity. You may change, has it been edited? What value was it previously to the latest edit?
Is it like we have
Logging everything that where that entity, what happened with that entity.
It's separate from logging, but it keeps track of the state of that entity
Where does it do that?
within entity framework.
Within the database or
No, within the entity framework code. In memory, yeah.
It's only really useful to me if you're doing it in a client-server application, which
WinForms or right.
and
Yeah, a lot of people doing web development, where you're supposed to be developing stateless apps. You aren't going to necessarily use a lot of tracking. You're using WinForms apps where you don't want to have to go read the data from the database fresh if you already got it in Entity Framework. It keeps the latest value in there, tells you what it was previously and the state, whether it's been changed or not.
It loads all, if you have a customer, order, and product, it will load all three data sets, multiple data sets.
Well, that's a separate concept, yeah.
This is the dirty versus clean, how I changed it for.
That's pretty much. Yeah. So now is this longer or shorter than the last, these times, are they longer or shorter than the last graph? Well, trick question, because that's microseconds, that's milliseconds, and so here we're looking generally, low to mid 30s, right, for a lot of these times. Here we're looking at 1.5 microseconds. Why might that be different?
Well, you said it could run multiple programs at that point of time and process only existing processes running other processes.
So I was hitting the exact same schema with the exact same data in a database, but the databases were located in different places, right? And one case, the first one, that's more real life. That's out there on a network as a separate server. This is sitting on my desktop or my laptop right there, database server on the same, in memory, accessing the database. Well, of course it's going to, in general, it's going to be a lot faster because there's, you don't have the time to get between the two machines, and you're doing things in memory instead of having to pass them across a network, right? So this is where I see a lot of benchmarks being done. A developer's got his local machine. That's where developers like working, right? On their local machine. They're not out testing real life scenarios on the network, and they're saying, well, darn, I'm a whole lot faster if I got Dapper running. Yeah, you're a whole millisecond faster. Would anyone here that can tell the difference in a millisecond? I didn't think so. Yeah. A bunch of milliseconds, right? So, but that's the point is, so here you look at, for all practical purposes, most people aren't going to be able to tell the difference. So why would you spend? In this case, it was a 200 megabit per second connection to the internet via charter. My Wi-Fi typically only handles about 104 or 5 down. So that was one of the constraints in running this. This is about 5 to 6% of the time because now you don't have the transfer between the machines involved. This one, yes, if you want to be a purist and you want to say, Dapper itself was a little bit faster, or that was a little, you can say that. But what other concerns do you have in development? Are they about that couple of microseconds or half of a millisecond difference? How much more are you willing to pay for that as far as development effort? Depends on the app. There are some apps that you may need that, absolutely.
Are you saying that Dapper has more development effort than ES, for instance?
Yes. Yeah, Dapper one. We'll get a little more into comparisons, pros and cons of the different frameworks in just a minute. First, we got to understand, I showed you the differences. Now we got to talk about why are those differences, the data retrieval time. You got to look at the time for SQL Server to return a set of data. Now, is that always the same? Now, how many cores are on the machine? What kind of drives? Do you have solid state drives on the machine? How's your caching? How large is your cache? Do you have your execution plans cached? All these different parameters come into play on that server. So from server to server, you'll have a difference. Then you got to talk about the time to transit from across the network from the client to the database. Now you have other constraints, right? What are my bandwidth constraints? Do I have a gig pipe? Do I have a cellular to, like we'll probably see an example run across here to go out to Azure, using my cellular connection. Oops, wait a minute. And, are we making multiple calls or are we doing it in one? Right? If you're sitting right on top of that database server, multiple calls, you might not notice it right away. But now when you got to do one call and then it makes a whole bunch of other calls based on that, if you've separated the two and one's on the internet across the world somewhere and you're trying to get over to here, those multiple calls will take a whole lot longer to get done. How many rows of data are you returning? How many columns of data? They all play into how big, that set of data that's coming across. The bigger it is, the longer it's going to take. Then you need to talk about how long does it take to get the data into the model. The data itself usually is no good all by itself. You somehow have to show that on a UI somewhere, right? So you end up putting this into some model that then you can display. Well, that time it takes development effort and it takes time to do that. And then you could have other processing involved in the application, filtering, sorting, aggregating, all those things take time. So just all I'm saying is when you look at these benchmarks, don't take them at face value. Think about, a lot of times people do these benchmarks trying to show something and prove it a certain way. Entity framework's slow or Dapper's fast or whatever they're trying to prove. That's a lot of time what they will prove. If you're going to be a good architect, knowing all these different aspects and then being able to go out and do tests to prove it make a difference. So let's look at entity framework advantages. Quicker, by far, quicker development, which translates to reduced cost. I know when we first started using ORMs, even before entity framework was around, I saw development time on the WinForms app at that time that I was working on cut to about a third when we went to using an ORM tool. And I know today with web apps and all, they'd take at least twice as long if I weren't using entity framework. It's easy to keep your database in sync with the front end using code first, right? You do your migrations, they're in your code, you run the app, and the migrations get run. I don't know how many shops I've been in that are trying to roll their own, in fact, most of them don't even try and do that, right? They just, this developer has one version of the database, and this developer has another version, and this client has a different version. And now the client's having a problem, and depending on what developer's looking at it, he may or may not be able to troubleshoot it because they don't even have the same schema, right? Oh, I forgot to run that stored procedure, or that script to add this column or to add this stored procedure. When you start doing things with code first and migrations, it's hard to forget them. The strong typing reduces your chance of errors since you catch the issues at design time instead of runtime. You guys writing ADO.NET, how often do you, QA, or clients end up finding an issue because your strings that you typed didn't necessarily match the strings in the schema of the database? You mistyped something. You don't want to find that out when you push this thing out into production. You want to know, when this app goes to start up, that these models don't match, or the context doesn't match the database, and that there's a problem. Change tracking for those type of applications, especially like WinForms, WCF, or something, where you may be maintaining state in your context. That's a plus. Instead of everything, your data is kept updated, and you don't have to go out and pull it fresh from the database all the time. No, it's kind of an added, this when you have the context, the context can be local, and it can keep all the data that it's already accessed from this database. So it's kind of caching it locally so that you don't have to go back out to the database and pull that data in again if you've changed it locally. Okay? So that's what I'm talking about with the context. But it doesn't, in the web apps, that's not very useful, but in WinForms, WCF, apps like that, you may find it useful. When you're dealing with ADO.NET or Dapper, you got to deal with transactions, right? Well, what if, when you deal with Entity Framework, when you do your save changes, that's all wrapped in a transaction and taken care of, right? And the other side is, and this doesn't apply to those, how many of you were doing SQL before .NET? And always start database first, okay? I go back then too. So right. So, for you guys, well, this doesn't apply because you're comfortable in database, and you start doing your development from designing your data structure instead of starting from the object-oriented side of what the client's looking at, right? But for those that are more recent inductees to software development, they like the concept of this universal language. Like, if you think about it, when you're writing SQL, you're starting to write columns before you even know what table it is. That always seemed backwards to me. I don't know to you guys. Because how can I know what columns I want to pick until I know what table I've picked? So LINQ is a different way of looking at it, but not only can it be used on SQL Server and Oracle and various web services, and a lot of different products can put a LINQ interface over top of them, and you can access them just like you were querying a database. So now someone that knows LINQ can write code, now it's in your code instead of, a lot of the old school, everything was in stored procedures, right? So now you've got logic and business logic and stored procedures. You've got business logic in your C# or VB.NET, whichever it is. And you probably have a reporting program like Crystal Reports, and you've got business logic in it. Well, what if you could centralize a lot of your business logic, say, look, it's going to be in a database. I'm going to use LINQ. It's going to go ahead and create the SQL that I need. It's going to take care of. How many of you that are still writing ADO.NET are really, really careful about SQL injection? You got to be, right? But a lot of that's taken care of when you're using Entity Framework and LINQ. So, no, well, everybody writing code to the database isn't using stored procedures. And in a lot of cases, they're doing the select this from this where something equals, and they don't put a parameter. They don't parameterize that query. I see it all the time.
There's a rule we parameterize our SQL or our stored procedures as well. When we're calling those,
Yeah.
we use parameterization as well.
Yeah, and you should be parameterizing things, but the point being is some of this is given to you when you're using a tool like this. It's keeping you out of trouble. It's giving you the ability to use the same language or syntax across different data sources. And in some cases where the database might not support something, LINQ will still turn around and do it in memory, right? So if there's some aggregation that you can't do against your specific type of database, now if you've written a LINQ, it says, oh, well, you do everything you can against a database, now do these other things in memory. So you end up getting the same result with it. Now, there's some gotchas, and it can bite you on some of that, and we'll talk about some of those too. So,
the code first, say if you have like a database which grows like incredibly big over the time, will your source control file not become very big because all the database data will be stored in C# logic?
no, I don't think you're going to bump up against any constraints there. I mean, I've had multi-million lines of code. Yeah, I mean, you may have a whole bunch of migrations, and
User data becomes really big over the time. Is all the user data does not come in C#?
The same data that if you were writing in ADO.NET versus you were writing it in LINQ, the data requirements are still the same. Nothing changes there.
The way to think of the user data is it can be either things that you would go ahead and migrate into your database when you set it up, or it can be the stuff that the user enters. The user data that the user is actually entering is typically not getting built into the code. So it's not, you're not creating a copy of the database in code.
Right, yeah, and you'll see when we do an example, you know, you write this code that has the entity framework or link in it, and it's going to output a parameterized query of, you know, whatever so you type something in, that's the value that it uses in it, but the data that gets stored is exactly the same whether you've done it with ADO.NET or whether you've done it with LINQ. So let's look at, first I want to look at an example. Why entity framework? Okay, so typically, this is one way. I mean, depending whether you use data readers, data sets, they give you plenty of options, right, when you're dealing with ADO. So you'll come in here, you'll set up your SQL command, and then hey, we parameterize it. You got to parameterize things. You can save a few lines by not parameterizing it, but then you're going to get yourself in trouble with SQL injection, right? So you got to have that. And now we're going to take our reader. I chose the reader because the reader is going to be faster, right? But now I got to get it from the reader. So all this code now is to get it from the reader into my model. Now if I did that, any framework link, that's it. Which would you rather write? Got any questions? Anyone that liked the first one better? I didn't think so.
And then you have to like add like a CRUD stored props, like create, read, update, delete stored props. At some point, I was able to cut down 1,000 lines of code to 20 lines of here.
Yeah.
And you also have to declare the properties and everything. Yeah, all that stuff can be eliminated.
Yeah. So what? We went from 10 to 48. So 38 lines versus 8 lines, 9 lines, whatever. And really, one real line of code there. That's the only one you had to think about besides that you're rapidly using to deal with any exceptions that might be thrown. And to dispose of it.
And it's also return like a list. It's already casting
Right.
a list of a player.
Right. It's already a list. So all this code here is that one line of code that you see below where it's cast to a list, or it's the to list part of that. So that's why I say you easily cut the time to a third because how much less code we were having to write on this end. So let's look at Dapper. Dapper's faster. It's a micro ORM. It doesn't have all the overhead that you have with Entity Framework. So it can be faster. Now, it means you have to write more code because it doesn't have all the stuff added in for the change tracking and all the other things you can do. Now, where it really stands out, and I had a client that, just out of habit, it's like, oh, I'm going to use Entity Framework here because what I didn't understand when he told me that the schema sent me a database, he didn't tell me this changes on a daily basis. So I created entities off of that schema and wrote the program. And I send him it, and it doesn't work. It's blowing up on connecting to the database. And, we start digging into it and comparing schemas and, oh, well, I've added these columns here and removed this table here and moved it over to this database. And it's like, whoa, wait a minute. You can't do that. So the next project I worked on for this client used Dapper. Dapper doesn't have, quite the checking and everything in place that any framework does, but doesn't lock you in as tightly either. So if a client, if you're in an environment where they're seat of the pants and they're making all sorts of database changes, don't go with Entity Framework. Use Dapper over ADO.NET because it'll save you writing a lot of code. But yeah, that was a lesson learned. And there's less code than ADO.NET. Yes, sir.
I'm not familiar with Dapper, but the way it sounds like you're describing it, does it automatically update in similar ways like context?
Yeah, we'll look at. Okay, so let's. Good question. So the question was asking how's Dapper different than Entity Framework? And let's look at a. We'll go to benchmark. Yeah. Dapper repository. So here's an example of some Dapper. Can you see that okay? So it's a lot less code than you would have in ADO.NET. And there are some plugins, Dapper plugins or add-ons that you can get that'll add some other functionality to it too. But in this case, we're saying, so we set up the connection, we're going to query return a single result, and then here is, now you know my feelings on that, right? Magic strings, when you find out there's a problem, is runtime instead of design time. So there is an add-on or something you can do that'll add some type safety to this, and you can approach it more like Entity Framework rather than just typing in a string. And here it is, parameterizing the query. Okay, so it is going to take care of that for you with a lot less effort than what you get for ADO.NET. So, in the right place, I think Dapper's great. I tend to prefer Entity Framework in general. But when I have a database that I can't guarantee what it's going to look like because I don't control it, then Dapper's a good choice.
I don't know how you run an organization on a database that keeps changing all the time.
If you want an answer, go talk to us.
Yeah.
In that situation, they can use NoSQL database.
You're correct. They don't understand that they're causing themselves a lot of problems by changing the database constantly. They think, well, I can make this a little quicker. I can take this data here and I can do this to it, and then I can make a copy of this here because it's in the same database, and now I don't have to go cross database. And they've got the same data in 3 different tables across 3 different databases, none of which is right. You're right. I can't argue with you. It causes problems. But the reality is there are people out there doing that. And if you're writing a program and having to deal with it, then don't choose Entity Framework, choose Dapper. I'm not saying I agree with the premise that it needs to change like that.
But if it just select
Dapper, you wouldn't be in that situation.
Yeah, I didn't control the database. I just had to make my program work with whatever their database looked like. Well, no, Dapper is just more. You still have to.
I don't know what the database looks like before it's even going out to the database because it keeps changing all the time. How does it even know? How does your code know just because you're using Dapper that, oh, this database changed? It's not the same thing.
It supports. So the question is, how does Dapper know that the database changed? And Dapper doesn't know that the database changed. But Dapper is more resilient. It doesn't lock you into that structure, that schema, and say, oh, you can't run because I don't like your schema. It lets you run, and if you add columns, as long as the columns you're calling in your query are in the database, it'll run. No. There's certain changes in any framework. Your context is supposed to agree with, so it can do some of the things it does, your context has to agree with your database to at least some level. You can get away with adding some columns and things to the database, and it doesn't always complain. But that's a problem on any app if you're going to use to access the data.
So in the entity framework, can we do like a stored procedure so it can handle like what?
Yes, yes.
Dapper kind of thing? No.
You can do store procedures from either one of them.
Yeah, I mean, I'm saying if we use entity framework with stored procedure, it may be more adapt to the change. That's what I'm trying to say. The same query concept in Dapper, the same queries could be put in stored from entity framework.
Yeah, let's not complicate it. The Dapper will be more resilient and flexible to a changing database, whatever that means. And Entity Framework wants your database, your schema, to more closely match what it has in its context. ADO.NET, the only really good thing I can say about it is when you're talking about a millisecond, it might be a millisecond faster, but that's not your big concern. We can talk about it afterwards if there's some issues. I don't want to get derailed and yeah. The kind of questions you're asking are really a whole other entity framework presentation, and I'm just trying to give you some guidelines for when you're trying to choose between them. Why would I choose them? And it's with anything. Just here's some guidelines, and then when you get ready to, wait a minute, I remember hearing this, and now when it gets time to implement it, you dig a little deeper, but you remember hearing something. So I say it's faster than an entity framework, but you got to end up writing a whole lot more code with ADO.NET. Real quickly, I'm not going to go into any detail on it because I don't want to blow too many minds. But you've heard of Cosmos DB and supporting the document database, relationship model, key value pair model. So everything that isn't the relational database, now those other paradigms are being handled by Cosmos. And there's other document databases like Mongo and so on that may cover one aspect of what's in Cosmos. And while Document DB gives you blazing fast reads and writes, it falls short on accessing data when you need to access it in a relational way. Okay? So every time I go to a different code camp, I'd go to these Cosmos DB presentations, and I talk, okay, so here's what I want to accomplish. Can I do this with it? Can I do this with it? And what I wound up finding out every time is that I could use Cosmos to get these blazing fast reads, and if I want to get the data right out into a form, looking exactly like, if the database was structured the same as that user interface, I can pull that data out real quick too. But now when I want to drill down and go across relationships, and I might not want, one time I might want to look at things by customers and then their orders, and then within that order there's these items. But now what happens if I want to do a query and I want to look at what items are the most popular, or now I'm not coming at it from this hierarchical approach that this document DB takes. They keep making some changes to say, well, we fixed this a little bit, but the bottom line is you either end up writing the data multiple times to support the multiple ways you're going to look it up, or you write to the document DB the way you're going to use it most of the time and to support your UI, and then you have a hybrid model, and you have a relational database that now you're updating with this data from your document database, and then when you're running reports, you're going out and either pulling from a relational database or something. It could be a data warehouse instead, with a star schema, something like that, a way that you want to read and aggregate data. So, but I haven't found any case with anything other than the simple app where the code that I'm writing anyway, with real-world apps, that I could just use a document database and not have a relational database involved with it too. I mean, has anybody come up with?
Mongo has Mongoose, which can do the.
Yeah, Mongo's is document DB, but like I said, I just.
There's an add-in called Mongoose for MongoDB, and that does the relational database.
Okay, I'm not familiar with it, so I don't know what it.
I work with
So you said Mongoose? I'll have to check that out. So, in conclusion, I use Entity Framework for most use cases. Then I review slow. So let's see, before we, we'll get into those. Then review slow and high usage calls. If scalability and performance are important, more important than the budget, consider Dapper. I mean, sometimes that performance is all important, and those milliseconds here and milliseconds there, you can't afford them. There are those apps. So that's where I'd recommend Dapper. If money's no issue and you need to scale like the next Google, you can look at a hybrid NoSQL and relational database. Maybe something, like Bonner says, Mongoose, I don't know, I'll have to look at it, because if I could find something to fill, it just writes data different. The NoSQL databases, they don't care about a schema. Relational databases, we're used to a schema. I know, this will really blow your mind. They don't have a schema. Or not a predefined schema, anyway. Some products, probably like Mongoose, come in and then say, here's what we think your schema is based on the data we're finding. So let's look at Entity Framework performance, since in most cases I'm using that, and looks like from the hands out there, most of you are too. I'm going to talk about a few things that are gotchas. They're really low-hanging fruit, easy to find, easy to fix, and will be most of the problems you'll run across. Now, I got about 10 of them, but I'm only going to run through a few. And if it's worth something more later, we'll figure out what to do for that. So, as far as tools, Visual Studio has you get diagnostics tab, and we'll look at that in a minute. As we're going through the performance, everybody here uses SSMS, right? SQL Server Management Server or Studio. SQL Server Profiler. Stackify Prefix is a pretty cool tool, but I think a lot of that nowadays, Visual Studio Diagnostics will give you the low-hanging fruit anyway. Redgate has some cool performance monitoring tools, and JetBrains has some too. So now I guess it's time to look back at code. So let's look at a problem. What's that? Like that? So, what are your thoughts on that? Any ideas? Okay. Okay. So the demand in the front says you probably don't want to list it there because it's going to pull back the whole table, and then it's going to go ahead and filter out what it doesn't need. Okay, so yeah, we probably want to prove that, right? So let's run problem 1. Let's set that comment. And hold on, we gotta be able to get to the database. So give me a minute here while I can't see things locally.
I can learn to understand you much better if I can get familiar
Yeah, go
with the way
away.
you talk.
Maybe later.
Information to help.
Got it. Yeah, annoying. She does that to me all the time. So let's see. We have a no internet access. Okay, so it looks like it did just connect. So now we should be able to get out to the database, hopefully. And gotta make sure we got it in release so it doesn't complain. And we're missing some. Yeah, my tools were being cut off on the side of the screen, so I wanted to resize it. Come on, are we going? We running? Okay, and events. All right, so what I wanted to show here is you've got a filter that lets you set ADO.NET. So as your app's running, it's going to intercept your ADO.NET calls so that you can see what it's running. And here, you can see I'm in, well, I don't want historical debugging. But you can see here, if I can, it's showing you the code. And you can click on it, it'll bring the code into it. You could access a database right from here from Visual Studio. So you could take this, cut and paste it, and run it, right? So this is showing you the same, the entity framework had spit out this code, this SQL, for you. You can just take that, run it in your data tool of choice against your database. Okay? But you can just see by, so this ran a different, looks like it's showing problem 3 in there. Yeah, it looks like we ran a little more than I was expecting it to run. Let's look at I wanted you to see that he was right. Yeah. Couldn't convince you that that was the right, or couldn't convince me anyway, that was the right query for what I thought we were supposed to be doing. Let's comment that out. And yeah, so let's. And what you'll see is there's no where clause on this. The filtering is being done in memory. And that was one of the things I was saying by using link. Yeah, it's nice that it takes care of that for you, but it allows you to do some things that maybe you shouldn't do sometimes. You know, so if you hadn't listed it, and when we look at, so you're not, if you see, I'm going to show you a window over here. So this was it actually running that program one, and here's the list of data that it was spitting out. And then if we look down here, now you're seeing what you expect. Only the one query. Not enough real estate to play with here for an IDE, is it? Yeah, so it's just, here it is, select from that, and there's no where clause on it, right? Now, if we looked at the fix to it, okay, you'll notice there's no toList at this part. It does the whole thing with the where clause, then it toLists it all here. So what that does is it tells SQL, add a where clause to it when you run. And once again, when we look at the ADO.NET, we'll see that it looks a little different. And now I've got a where clause, and it's including a date of birth. So it's going to be faster because you're not pulling all the data in the table across to get a few items.
Select with the where clause rather than select all.
Right. So that's easy to do because people get used to toListing and then doing some action on it. You know, defer that, compose your link. You know, you can add a bunch of these statements together, and then when you need to toList it, toList it.
There's a good, Fusion has like a lot of 100-page books, and there's a good 100-page book on link. Like they got 100-page books on almost everything.
Okay, we're going a little more challenging here. Oops. Looks like link code people write all the time, right? What's the gotcha there? Let's see. Oops, sorry. Let me go. I'm going to go ahead and run it and let you see. See why I didn't want to run through all the tests up front where we're testing the entity framework and no tracking and all that. These are just simple little queries, and you see the delay. Okay, anyone see the issue yet? So, we come out on this first one, oops, and we look up the data in the main table driving things. And then that other little part of data we're getting from that other table, we're going out and getting one record at a time. It's called lazy loading. This has probably been Microsoft's biggest thorn in their side related to entity framework, because they get, when performance is bad, they get blamed for it, right? So with .NET Core entity framework, Microsoft said, we are not going to let you shoot yourself in the foot anymore. We are taking lazy loading away from you. And of course, you know what happened, right? The developers started screaming, we got to have lazy loading, we got to be able to shoot ourselves in the foot. And I wouldn't do that anyway. It's only this other stupid developer that would. Nobody would do that. Yeah, I see this all the time. It's when you least expect it. So, but they compromised. In 2.2, I think it was, they added lazy loading back in, but they require you to use a proxy and override the base behavior to do it. So in other words, if you shoot yourself in the foot, don't blame them, because somebody on your team anyway did it. You might not know he did it, but somebody on the team did it and shot you in the foot for you. So to give you this behavior, I went and added the proxy in here, because otherwise I wouldn't have been able to show you this example. Now, prior to .NET Core, you could do this all day long. In fact, you probably are and don't even know it. But if you're using your diagnostic tools, and that was the big thing I want you to get out of this, I mean, I rarely see people using these diagnostic tools and looking at this SQL that's being spit out. Take the time, run it. You can just run your local machine, and you'll see. I mean, pretty obvious, isn't it? I was expecting one call, and I got back 101 calls to the database. That's a big performance killer, especially when you're going across a network or across the internet. So what you do, let's see. So I don't know if you can see the difference here. But we're doing, see there's no include in here? So we're telling it, let's get the players right up front while we're doing it. So I'll have that player information available, and then the query will look much nicer. So let's rerun this. Oh, I guess I should probably break first. Yeah, wait a minute. We program. Got it in two different places depending on what I'm trying to do. One was the other one is to do the benchmarks. This one is so I can go right out to it without going through the benchmarks. Always seems to take so long when you're standing up here in front of a camera, right? Let's look at the diagnostics. And instead, we have two queries being run. One which is getting the players, the other which is getting the teams. Okay, so we do it much faster than the other way. Now we could look at that. Yep. Just for grins, let's run the benchmark. And do the fix. And the original. So this way you can see, I want you to see what happens. I didn't want to do a bunch of these where you got to wait through it, but now you can see what's going to happen when we do the benchmark runner. And let's see if I can bring up the, as it's running. So this is what you'll see running through the benchmark process. And it does a bunch of work up front before it generates that table. Anyone got any questions while we're waiting for this to happen?
With the benchmark decorators, do you need to worry about those once you go to release mode? Do you need to clear those out, or do they just get ignored?
Well, you have to run this in release mode for the benchmark runner to run.
So I guess what I was wondering is, if you put a benchmark tag on a method, and that method runs into your production environment, does it slow things down to run this, or you need to make sure that's just a test call?
Yeah, it's purely academic for testing. Yeah, you just wouldn't be real code. The other examples where, you know, I got mixed up a couple times and undid the wrong one, that would have been the real code that you're using. The benchmark one is essentially calling the same call that one was, but it wasn't forcing it to be in release mode. If you're using the benchmark program, it doesn't want all this other overhead when it's creating benchmarks.
So you would want to run that as its own test app rather than
Yes, yeah. You would not have that in your production code. So you'll see here, it ran through all of them. It gave you some warnings like, hey, the time was so low, you know, maybe that isn't a good example for running. And you see here, slight difference in time. That's obviously different, and that's what lazy loading can do to you. And that's not a huge database. If, you know, I'd had something with a lot more calls, it could have been a whole lot longer than that, you know, 59 milliseconds. And so you'll see there's some other, you know, try to give you some pretty graphs and all that. But what I found useful was that, and I can cut and paste it into Excel and, you know, send it to people then. So, oh, hey, how'd that get up there? All right. So I just showed a couple of the examples, but other things to watch for in addition to too many rows, and that was the N+1, that lazy loading issue, right? The too many columns. I know nobody uses select star, right? Where you just bring back the whole, all the columns and all that. Well, avoid that. You know, you got to watch your nested links sometimes when you get into that, and issues that can be caused with it. Data type mismatches. Okay, they're much subtler. How many of you are familiar with in SQL Server Management Studio with execution plans and seeing client statistics? Let's just take a second and hit that, so at least you have a feel for it. Yep. Okay, come on.
We got missing indexes up there. We had a serious issue where we had a query run for 15 minutes,
Yeah.
and we decided, we found out where the problem was, put an index on that column.
Yep.
It went from 15 minutes to 7 seconds.
Yep. Yeah. Yeah. No, I've seen lots of those. We're just having to write in. Now, over-indexing can cause problems too. But so here's one of, I cut and I removed the parameter just for simplicity to make it just select where. And I put a date in, and that was one of the queries that you saw earlier that was generated by the system. And I can come up here and I can choose, this here says, include actual execution plan. That's the plan SQL Server is using to build the query and get the data, right? That's what it's going to use, or has used. And in this case, when I ran it, this is what it's saying. And now we're not going to get into how you optimize execution plans. That's not the intent here. I just wanted to make sure everyone knew that, from your diagnostics panel, you can take that data, you can throw it in SQL Server Management Studio, you can run it, and from here, you see that if you're doing, scans, well, could I be doing a seek instead because it's a little faster? Or if I'm doing table scans instead of index scans, well, those are even slower. So or you can bring this to the database guy and say, hey, here's this query, here, slap this in the Management Studio and let's see what we get. And, because if you have a database administrator, a lot of times they understand what these execution plans are, what these statistics mean, and you can run different runs. And here you see I've run it 4 times. Sometimes the impact was it got better, sometimes not, and it'll tell you how many rows are returned, how much, how many round trips. So if you want to cut down on your round trips, the size of the packets, and so on. So all that information is in here, and you can see if your changes have improved it. But sometimes if you've got the wrong data type, like something that would be nvar char instead of an nchar or something, you could be doing it either way depending on how you set it up, and it may not map directly to what SQL Server is expecting. And so when you see some bad performance, you'll be able to pick it up in something like this, right? You can add an index. In fact, that's what I did between some of these. It's like I went and added some indexes and said, okay, does this improve it or not? And then run the SQL again. Now, do you need to do that for everything? No, probably not. But for that 10, 20% where the performance is noticeably lagging, cut that out of your diagnostics window, put it in Management Studio, and take a look at it, see what it tells you. So missing indexes, overly generic queries. In other words, how many of you have written store procedures that up at the front of the store procedure, you're doing lots of coalesces or checking for nulls, and if nothing's passed in, then you skip that part of the store procedure, and if something's passed in, you add that to the query in the store procedure that's building. Well, when you create those overly generic queries like that, it's hard for SQL Server to optimize it, right? It'd rather have more specific, know that I'm going to always have this data, this data, this data to work with, not I'm generating a SQL in a stored procedure where I may be skipping certain things in it. And I know in the day that was a very popular thing. I mean, I did it in the day, but not anymore. Plan cache.
Can you create an execution plan for these overly generic queries every time?
What it typically does is it caches one, and then it tries to use that plan cache, and sometimes it doesn't work real well. Yeah. Another thing to keep in mind is, do you have extra work going on the client side? Once again, we come back to change detection that we talked about, or change tracking. Two different things. One's to know that it's changed. The other's to know what the value was prior to the change. Note that these things they increase non-linearly. They go this way. So as the data set size grows, it gets exponentially worse. So small data sets, change tracking, change detection may not take any time at all. But when you're working with large data sets, that's where they're really going to bite you. If you're really into enhancing or optimizing things, and you don't like that slow startup, well, first you got the .NET slow startup, right? When the first time the app runs, and then you also have Entity Framework. There's some of that too. Is it's checking its context with the database schema. So, there's a lot of checks going on. So you can engine things. You can, and if these terms don't mean anything, don't worry about it. You can always get the slides, and you can look back at what kind of things can I do. They're beyond the scope of what we're talking about tonight. Pre-compiled views, and don't use giant contexts. Okay, you got this context that has 300 or 400 tables in it. It's going to take a while to load at first. So if you can do with a smaller context, like these users are typically, HR, and here's the tables they use, then you use those HR tables. And then the maintenance guys are using these tables. You put them in another context. So nothing says you have to have one context per database. Some other helpful tips. Not this is just performance in general. Use dispose, or using, right? Should be doing async. You can use multiple result sets on a connection string, right? You don't have to just do one at a time. You can pass multiple through. Now, when you start getting into caching, it can really help your performance, but then you start getting into having to figure out what the edge cases are, how stale the data can get, when you got it. So it adds a level of complexity that is really easy to make a mess of fast. Upgrade. Each version improves performance. I've seen, as we went from .NET Core 1 to 2 to 2.1 to 2.2, each one has been better. So now, don't assume that 2.3 or 2.4 is going to be better. Go get benchmark.net and run your own benchmarks, and you'll know for sure, right? Test with realistic data. I know all of us have these tables with a dozen or two records, and maybe we've duplicated them a few times, so we have a couple hundred, and our clients are running with millions. You're not going to feel the same. Look into using other data access approaches where performance is more important than is what's gained using EF. EF isn't the answer to everything, and I'm not standing up here to suggest it is. Hopefully there's been a little balance between, when I'd use it, when I wouldn't. And even with any framework, you can still use stored procedures. Yeah. Don't use them at the level that, as old timers used to use, where you had to have one for a delete and one for an insert. And I threw out the thought of a workshop if someone wanted something more intense. I don't know if that makes sense for anybody, but I'm willing to do it if I can get enough takers. If there's not enough takers, won't do it. Didn't have enough takers.
You're going to do it online, or
It'd be over the week. It'd be over a weekend somewhere.
you come to Greenville?
No, if there's enough people down here, I just come down here. And so I was looking at the first 3 hours being training, and then like lunch, and then 3 hours of if you got some app or something that you want to spend some time going through and optimizing. With myself here and others here, we could go through it and figure out how to make it faster. So if you're interested, send me an email and let me know. That's my email address. I guess that's the end.